Hi. In this video, I am discussing a question based on mathematics, mechanics, that is free fall. Okay, whether the question is based on mathematics or physics, whatever it is, the principles are exactly the same, nothing different. But when there's a question in physics, it will be mainly based on numerical values. Say, for example, the question will be given as like initial velocity is 2 meters per second. The acceleration will be given with a numerical value. The time will be given with numerical value. But in mathematics, that is in mechanics, A level, the questions could be without any numerical values, but they can be given with alphabets like a initial velocity u, the time taken is t, the acceleration a, like that. And also in mathematics, that is in mechanics, uh, the questions can be heavily depend on mathematical operations, something like calculus or maybe differential equations or calculus or maybe even algebra. Like that, it can depend on that. But remember that whether the question is in physics or mathematics, the principles are exactly the same, nothing different. Okay, so this is the first question based on free fall motion under gravity. Okay, I'll give you almost 1 minute to just to read the question. Yeah, first question. Okay, so good. If you like, you can try this question and you can try to answer these three parts of the question before I explain it. Okay, so I drew a diagram to describe the whole question. So t equals 0, that is initially the ball x is thrown upwards. Then after time t, the ball y was thrown. So that time the x will be somewhere here. It might be going up or started falling down. We don't know. But I took it, it's going up. Still, it's moving up, right? Now, at time t equal t1, they are colliding. Okay, just before collision, I showed a small gap just before hitting each other. The height is h. So, at a height h, they are hitting each other. Okay, so the idea or the principle in this question is we know that when you throw a ball vertically upward, not only a ball, any object, when it is thrown vertically upwards, it will go vertically up, decelerate at the highest point, the velocity will be 0, then it will fall down. Yeah. Okay, so here the first part to show the time, I'm going to use the idea, this one. This is the principle I'm going to use that. This is the idea I'm going to use that. You know, when a ball is thrown vertically upwards, say for example, when it is at this position, if its speed is upward, if it is v1, when it comes back to the same position, the speed will be v1 downwards. Okay, so when an object which is projected vertically upwards, when it comes back to the same position as earlier when it is passing that, it will have the same speed, but the directions will be in opposite to each other. Same way when the ball was moving up, when it is here, if the speed is vertically upwards, v2, when it comes back to the same level, the speed will be downwards, v2. Right. So I'm going to use that idea. So here, two different balls x and y, they are projected from the same initial point from the ground at the same initial velocity u. So both will have exactly the same path. They will follow exactly the same path because both are projected from the same initial point and both have the same initial velocity. So now look at it, this idea. The ball y is moving up. If it wants to hit with ball x, the ball x should come down. when they both are moving up, they never collide because both are decelerating, and this ball is thrown later. So when they are moving vertically upwards, they won't collide. One should come down and the other one should go up. So in this time, at time t equal t1, so the ball y was thrown at time t from the time the x was thrown, but at time t equal t1, they are colliding. That means the ball y took a time of t1 to hit the ball x. So when they are hitting, both will have the same speed. Or I can say both will have the same magnitude of velocity, but the directions will be opposite. Because they are hitting at the same at a particular point. When the ball x come back to that point, it will have the same speed as the speed of y. So I can take that speed of x downwards v, speed of y upwards v. So I'm going to use that idea in this question to answer the first part. Okay, so I'm going to use that idea. Both will have the same speed when they collide. Just before collision, they'll have the same speed. Okay, so I can use for x. So first part I'm answering. For x, I'm going to use upward direction, v equal u plus at. So x is in motion for time t plus t1. So the velocity of v, careful, velocity of v, I know that it's downwards. So I should use this equation downwards, not upwards. It should be downward direction, because if I use upwards, I'll get a negative value. The numerical value will be negative. I'm going to equate the speeds of v, speed of x and speed of y. Speed of x is downwards, that is positive. Speed of y is upwards, that is positive. So I must use this equation downward direction for x, because I know the x is moving downwards just before collision, right? So if I use that equation downwards, we know this is a vector equation. So I should use the proper sign. I'm using downward direction, and I know gravitational acceleration also downward direction. So speed is velocity is downwards. So I can use v equal, the initial velocity was upwards, so it should be minus u, plus acceleration is downwards, that is g times t plus t1, minus u plus g into t plus t1, take it as equation 1. Same way for y, if I use the same equation v equal u plus at, that should be used in upward direction, because y is moving up just before hitting x. The time taken by y to hit x is t1. So for y, I'm using vertically upwards, v equal u plus at. So that is v equal, the velocity is upwards, so u plus, the acceleration is, you know, gravitational acceleration is anyway downwards. I'm using upwards, so it should be minus g times t1. The time taken by y to hit x is t1. Okay, so you take this equation, I can write again u minus gt1 as the second equation. Okay, so nothing actually. I told the principles are the same in physics and maths, right? So only thing here, instead of numbers, they are given in letters, U, G, like that. So the only thing I can do, I know both speeds are same just before collision. That's the important principle here, right? When a ball is thrown vertically upward, when it come back to the same level, it will have the same speed. Here, two different balls, but they are thrown at the same magnitude of velocity from the same point. So when x come back to this position, it will be same as the speed of y when it is reaching the same point just before collision. So I can equate both left hand side. So I can equate the both right hand side. So the left hand side is the same. So I can say equation 1 equal to equation 2. So use that one. So minus u plus g t plus t1 is equal to u minus g t1. Solve it. Minus u plus gt plus gt1 equal u minus gt1. So bring it to the right side, or bring this to the left side and bring this to the right side. So rearrange it. You will say 2g t1 is equal to, when it goes to the right, it will be plus, so 2u minus gt. So I need to find the time t1 first. I'll find it. So t1 will be 2u minus gt divided by 2g. So that will be u over g. So 2u over 2g will be u over g minus t by 2. Okay, this is t1. That is the time taken by y to hit x. But the question is time taken by ball x to hit y. So ball x is thrown already time t before. Right? So I can say time take. So I can write now like this: time taken by x to hit y equal t plus t1 or t1 plus t. So t1 u over g minus t by 2 plus t. Solve it, u over g plus t by 2. That's the answer. Okay, so the second part they asked to show that the speed of one of the balls. So speed, their speed. They said their speed because we know both will have the same speed. So their speed just before collision is half gt. Okay, I can use the equation v equal u plus at for one of it. Okay, if I can find it for y or x, I'll get the same answer. But I'll do both. Okay, so second part I can say we do it for y, I'm using upwards v equal u plus at, at1, the time taken by ball y to hit x is t1, and we have the equation for t1, that is u over g minus t by 2. We derived it in the previous part. Okay, so substitute this u upward direction. So minus g, instead of t1 substitute u over g minus t by 2. Solve it. It will be u minus u plus gt by 2. So they will get cancelled, half gt. That's answer for the speed just before collision for ball y. Okay, you can ask me if I do the same thing for x, will I get the same answer? Yes, I'll get the same answer. Okay, we don't need to do both, but I'll do it just for all. I can do it for x. So we know just before collision, the velocity of x is downwards because these equations are vector equations. So I should say velocity. The numerical value, the magnitude will be the modulus value will be the speed. So for x, I should use downwards, v equal u plus at. So that will be u is minus u. It was projected upward direction. A is downwards. G, the time taken by x to hit y is t plus t1. Okay, now substitute the value of t1 from this one. Okay, so that I can continue, that is I use blowing for this one. V equal minus u plus gt plus g into t1, substitute u over g minus t by 2. Solve it. So minus u plus gt plus g and g get cancelled, plus u minus gt by 2. So they will get cancelled. Gt minus gt by 2 will be half gt. So answer will be the same. Okay, so the third part, they asked to get an expression given, you would have read that question, for the height at which they collide with each other. So I can, here also, I can use it for either x or y, but I feel it's easy to do for y because still y is moving upward direction. So I can use the equation for the third part for the ball y. I am going to use upward direction because you know the displacement is upwards from the ground. S equal u plus v by 2, that's average velocity, times t. Okay, so the height at which they are hitting each other is given as h. I need to get expression for h. So h is equal to the initial velocity of ball y is u. So I should put u for that. U, which is upward direction, plus v also upward direction. But we got an expression for v. We already derived v equal to half gt. So I'll substitute that one, half gt by 2 into the time taken by y to hit x is t1. So it should be t1, right? And also we derived in the first part t1 is equal to u over j minus t by 2. So substitute that here. So rearrange it. So you can take LCM or anything. You can say 2u plus gt by 4 into u over g minus t by 2. Solve it. So 2u over 4, I'll separate it, I'm going to multiply. So 2u over 4, that is u by 2 into u over g. That will be u squared over 2g. Right? Is it correct now? So that is 2 here, u by 2, u squared over 2g. Then again, u over 4, that is u by 2. If you want, I can expand this and write. That's easy. That's easy to write that way. That is u over 2 plus gt by 4 into u over g minus t by 2. Okay, so multiply u squared over 2g minus ut by 4. This will be plus g and g will get cancelled. Ut over 4 minus gt squared over 8. Is it? So solve it. It will be u squared over 2g. So ut by 4, they'll get cancelled, minus gt squared over 8. Okay, take 8g as LCM. So if I take 8g as LCM, so h will be 8g as an LCM. If I take it, so that will be u squared 4u squared g 4u squared g minus g squared t squared divided by 8g. I took 8g as an LCM. Okay, so g won't come here. Yeah, 4u squared minus g squared t squared because g is there. So 8g, if I take it LCM, u squared minus g squared t squared over 8g.